So this week's lesson focused a lot on logical operators and making decisions. That was our key. And it harkened back to some of the conditional coding that we had done earlier in the course. So far, to this point, we've largely been just pushing Byte forward without too much thought. With conditionals, now we want to consider what to do on each square we land on. Byte evaluates the current situation. Is there a gem on the square I'm on? Is there something in front of me that I can't move through? Is there something to the left? Am I on an open switch, a closed one? We can ask Byte what answers he got for each of those questions by using properties like is on gem, is blocked left, etc. For each time we stop on a new block, we ask ourselves those questions. Am I on a gem? Is something in the way? When our code runs, we check to see if we're on a gem. We are, so we run the code in that block and collect our gem. But then we jump out once we collect our gem. In this case, we also want to turn right. So we want to make sure we cover cases where we're on a gem and we also can't move forward. So we might write a bit of code that looks like this, where we use the logical AND operator, those two ampersand signs. So you can see there, we check to see if we're on a gem and if we're blocked. Is on gem is true and is blocked is true. So we execute the code for our condition, which is to collect the gem and to turn right. Now, with a condition like this, we need to spend a bit of time to figure out which conditional is the right to use and which combination of logical operators is the right to use. Putting our check for is on gem and is blocked together might not allow us to solve a particular puzzle. In this case, we check to see if is on gem is true, which it is, and we see if is blocked is true, which it isn't in this case, because we can move freely forward. So we'll fall into the else clause of our if condition, and we won't wind up collecting the gem. Now, what we might want to use in some situations is the logical OR operator, which is these two pipes we can see between is on gem and is on closed switch. So if there's a more generic action we want to perform when there are a couple different conditions, like in this case, we have a gem. So we check to see if we're on a gem. That's one condition that we want to dance for. And another one is if we're on a closed switch, because in the puzzles, that means that we'll get the gem and be able to toggle the switch to open. So we'd use a logical OR operator in this case. In the book, they gave an example of Byte dancing if he was on a closed switch or a gem. So when we evaluate our situation, we see that we are on a gem, but we aren't on a closed switch. We'll still dance because we only need one of those conditions to be true to execute the true clause of that if condition. And then we'll move forward. We'll run our code again. We'll do a check again and we'll see, are we on a gem? We're not. We're not on a closed switch. So in this case, because neither is true, we won't execute any of the code inside our if condition, because neither condition was true. So we move forward again, and now we evaluate if we're on a gem. That's false. We are on a closed switch. So at least one of the values is true. So we're going to execute our dance code. So you're thinking, these are great. I can think of so many places I want to use these. Just how do I find those things to type? They might come up in the autocomplete bar if you're in Swift Playgrounds, but you can also find them on the iPad's keyboard above the A and S keys. Just tap on the key and drag down to add either the pipe, which is over the A, or the ampersand, which is over the S, to your code. You'll need two of each symbol for these operators. So the last logical operator we cover in the chapter is the NOT logical operator. So if we want to perform an action when a condition isn't met, we would use the not logical operator. And this is the exclamation point. On our block, when we get to that block, we would evaluate our condition. Are we on a gem? We aren't. So the condition would be false. But if we add the exclamation mark in front of the condition that we're checking, it would flip that false to a true. Now, that doesn't mean that we're on a gem. It just means that we want to cover the case where we're not on a gem. So we're going to execute that true clause of our if condition. So we'll move forward. Now we'll make the same check. It does the same flip because we're not on a gem. So it'll be true with the not operator. So we'll move forward again. And now when we do the check, is on gem is true. But with this not operator, it flips that value to false. So we'll actually wind up executing our else condition, which is we'll collect the gem. This one can be a little bit tricky. Maybe it feels a little counterintuitive. It's kind of like saying, are you not going to the party today? Instead of saying, are you going to the party today? It's just a different way of asking a question. And that's a lot of what we're doing when we're trying to make decisions with our code, is we're asking questions of our context and then making decisions and running code depending what answers we get. Thanks for watching.